Everyone, in this video we're going to talk about rational functions. Okay, we're going to sketch them. Rational functions are easy to recognize. And they have this fraction going on, where the numerator and the denominator are made up of polynomials. Sometimes something not too busy, just like a -2 over x squared minus 9. Or in this example, 2x squared over x squared minus 4. Okay, it's got the fraction going on. But these are rational functions. Polynomial here, polynomial here. And they got some interesting graphs. A lot of them have asymptotes. Yeah, asymptotes. There are vertical asymptotes and there's horizontal asymptotes. And I'll just simply call them the VA and the HA in our examples. We have two examples. We're going to sketch both of these rational functions. The first thing we want to consider is the vertical asymptote, the VA. To find that, that's where the function is undefined. Yeah. So we simply set the denominator equal to 0 and we solve for x. So if we do that, if we take this x squared minus 9 and we think what makes that a 0, because that's where the function be undefined, and we solve for x, we'll notice it's at two places. I'm going to factor this. It's at x equal to 3 and x equal to -3. So we found the two vertical asymptotes. And I'm going to label them here. I'm going to erase this. So I have enough room to make the sketch. X equal to 3 and x equal to -3. I'm going to go on this graph. 1, 2, 3. 1, 2, 3. And I'm going to draw dotted lines to represent my vertical asymptotes, because the graph isn't going to exist there. Alright, now how about a horizontal asymptote? To determine a horizontal asymptote, check out the exponents in the numerator and the denominator. If the higher exponent is in the bottom denominator, the horizontal asymptote will always be at y equal to 0, aka the x-axis. I'm going to put that here. There you go. There's going to be a horizontal asymptote right there. There's my HA. Y equal to 0. Here's my vertical asymptote, and here's my other vertical asymptote. I'll say that again. Your horizontal asymptote will be located at y equal to 0 if the higher exponent is in the denominator. See, that's x squared. And what's this? That's -2 times invisible x to the 0. Higher power was in the bottom. That's the most important part to the graph. Now what do? We have to come up with some points. Let's pick some x values to get this graph going. And the graph will bend towards these asymptotes. Yeah, they'll bend towards these asymptotes. So, let's see. If this is at x equal to -3, and this is at x equal to 3, I'll use a blue marker. Let's pick a point over here. How about x equal to -4? We'll plug it in. Let's pick a point over here. How about at x equal to 4? And I should at least get a few points in here. How about let's choose x equal to -1, x equal to 0, and x equal to 1. And we'll just substitute these into the function. Get the y values. At -4, you square that, you get 16. The point you get is -2 over 7. And of course you plug in 4, you'll get the same value because of the x squared. You get -2 over 7. I'm going to plot these. At -4 it's like a -2/7, and at 4 it's at a 2/7. And -2/7, which is barely right, barely off that x-axis. And I can make a huge portion of this graph because the graph will bend towards and approach that asymptote. And it'll bend and curve towards this vertical asymptote. Same thing over here. Curve and bend and approach that asymptote. It'll get closer and closer and closer as x goes towards infinity to that asymptote. We'll never reach it though. Well, I need some points. Something's going on in the middle. So let's see. I'll plug in a -1. I get -2 over -8, which is simplified to be 1/4. I'll get the same thing when I plug a 1 in there. if I substitute a 0, you get negative 2 over 0 squared minus 9, which is 2/9. So at x equal to negative 1, it's about 1/4. And then at 0, it was like 2/9. And then at 1, it was 1/4 again. Negative 1, 0, 1. And I can see this graph is doing this. So sure enough, if it's going to approach that vertical asymptote, we got this. It's going to do the same thing on this side. It bends and curves towards the vertical asymptote. That graph is finished. Okay? Yeah, we just substitute points to get the graph going. But the asymptotes are critical, all right? It's a key step. We do that first. And that's an even function, isn't it? All right, let's do y equal to 2x squared over x squared minus 4. Because in this example, everyone, the higher exponent is not in the denominator. So we're going to have to talk about the horizontal asymptote over here. Well, let's start out by finding the vertical asymptote, or vertical asymptotes. What makes x squared minus 4 equal 0? What makes x squared minus 4 equal 0? 2 and negative 2, correct? If we factor it just like we did before, we'll get x equal to 2 and x equal to negative 2. Those are the equations of the vertical asymptote. So here, I'll make a vertical asymptote, and here, I'll make a vertical asymptote. Let me get this out of the way. Negative 2, 2. All right, let's talk about the horizontal asymptote. If the exponents in the numerator and the denominator are the same, the highest exponent in the numerator and the highest exponent in the denominator are the same, then the horizontal asymptote will be the coefficient to those portions. And as you can see, I just boxed it off. That's a 2 over invisible 1, right? A 2 over invisible 1. That's the coefficient to this right there. All right? Yeah, you get minus 4. Ignore that. That's a 2. So, that's how you find your horizontal asymptote. Y equals 2 if the highest exponent in the top and the bottom are the same. So let me put that down. Here's my horizontal asymptote. Here's my HA. Y equals 2. Here's my VA. Here's my other VA. That's the critical portion to the graph. Now we do is get some points, get the graph going. Let's see. How about I'll choose negative 3. I'll choose x equal to 3. I'll pick some points in the middle. Negative 1, 0, 1. That should do. Let's see. If I substitute a negative 3 into x, I got to do it in the top and the bottom. All right, 2 times 9, that's 18 over 5. It's positive. Same thing's going to happen at positive 3. 18 over 5. Everyone, 18 fifths, right? That's 3 and 3 fifths, about 3.6. So negative 3, it's up 1, 2, 2, it's up around right here. Right? 1, 2, 3, be a little bit higher, about 3.6. And at x equal to 3, it's up around at 3.6. And remember, this graph will bend and curve towards the vertical and the horizontal asymptote. There it goes. But it'll approach this asymptote. All right? It'll approach it as x goes towards negative infinity. Curve up towards that vertical asymptote. It's going to curve down here. We put an arrow on both. Now, all we need are some points in the middle. How about negative 1? You get 2 over 1 minus 4. That's negative 2/3. At 0, 0 over 0 minus 4 is 0. And at 1, you'll get the same value. 2 over negative 3. I'll call that negative 2/3. So at 0, 0. Negative 2/3. And it's about right here. Right? That's about negative 0.6. And at 1, it was at negative 2/3. This graph will bend and curve towards that vertical asymptote. It's going to curve through here, and approach that vertical asymptote. Looks like we have another even function, huh? And the last example would be, well, what if the higher exponent was in the top? Right? We don't see that here. In that case, everyone, there is no horizontal asymptote. If the higher exponent is in the numerator, in the top, there is no horizontal asymptote. There's actually a slant asymptote. Okay? There's actually a slant asymptote. Rational functions.